Namaskar. Today we will discuss the meaning of scalar and vector function. Okay. Now we are familiar with suppose a function of x. Then we are familiar with this type of representation. Here I can say that f of x is equal to x square plus, say for example, 3x minus 2. Why we call this as the function of x? The reason is that the value of f, actually f is the representation of a function, but I can write this as a y. Therefore y is the function of x, means the value of y depends on x. And what is the dependency? Dependency is given by that function. It depends on x with the expression x square plus 3x minus 2. In school level also we had prepared the equation of line. For example, at that time we have mentioned that y is equal to, say for example, 4x minus 3. Then this y coordinate depends on x. Therefore actually y is the function of x. And by knowing the values of x, we can calculate the values of y. For example, suppose x is equal to, I will write from here, it is x is equal to, say for example, 0. Then the value of y is equal to minus 3. Correct? If I substitute x to be equal to 0. Suppose the value of x is equal to minus 1. Then here I will have to substitute x to be minus 1. Means it is minus 4 minus 3, it will be minus 7. If x is equal to 2, then I can say that it is 8 minus 3, that is equal to 5, and so on. Means this y is the function of x and y depends on x with this equation. That is, the value of y is given by this equation. Same situation is here. Now it is normal practice to write directly f of x instead of writing y is equal to 0, and therefore we call it as function of x is x square plus 3x minus 2. Here it was a linear function, only the first power of x. Here it is a quadratic function because it is x square, and there is a possibility that there are different types of function. In this case, we can plot the graph of y against x, and we can plot the function of x. That is, y is a function of x. Here we know that with the intercept of minus 3, the graph will be something like this, because we are aware about the nature of straight line. It is y is equal to mx plus c, therefore 4 is the slope and minus 3 is the intercept on y-axis in this case. Now suppose a particular variable or particular physical quantity depends on both x and y. For example, if I write here, suppose it is the function of x and y. I can say that z is equal to a function of x and y. I will write a very simple function. It is 2x minus 3y, suppose. What it indicates? It indicates that z depends on x and y. That is, z is the function of x and y. Function of x and y means it depends on x and y. Its value changes with change in x or change in y, with the expression 2x minus 3y. Now can I plot this on the graph paper? The obvious answer is yes. But it needs the third axis, that is z axis. Here for the particular value of x, for x is equal to 0, I can say that the value is minus 3. This. For x is equal to minus 1, that means if I think about minus 1, then it will be minus 7. It is below it. And for x is equal to, say for example, 2, here I can say that it is 5, somewhere here, and so on. Similarly, if I will have to plot the function of xy, I need the third axis. But on a plain paper, it will be difficult to draw on third axis, and therefore I will use one more interesting technique. I will write the value of that function at that particular point. Therefore, suppose I will have to write what is the function, that is z, at x is equal to 0 and y is equal to 0. Now, for a linear function which depends only on x, for different values of x, I can calculate the values of y. But here what I will have to do? For different values of x and y, I will have to calculate the z. Correct? I will have to calculate the z. Therefore, I will begin with x is equal to 0, y is equal to 0. If I substitute x is equal to 0, y is equal to 0, then the obvious value of z is equal to 0. And here I can write at this point the value will be 0. Means if it is third axis which is perpendicular to the plane of figure, then there will be the 0. Height will be 0. Now what will be the value at x is equal to 1? Therefore, if I write x is equal to 1, y is equal to 0, y is equal to 0, x is equal to 1, then the value will be 2. Here the function has a value of 2. What will happen at x is equal to 2? That means for this particular point the value will be 4. What will be, now I will not prepare the table because it will be lengthy and you will realize directly by substituting the values of x and y in this equation. Okay. What will be the value of that function at y is equal to 1? That means suppose if I substitute y is equal to 1, that is here, this point is x is equal to 0, y is equal to 1. And at that time the value will be minus 3, correct? Therefore, here the value is minus 3 means it will be below the plane of paper. This will be above the plane of paper at 2, this will be above the plane of paper at 4, this will be below the plane of paper. What will be the value of the function at y is equal to 2, say for example, it will be minus 6. And now if I will have to find the value at x is equal to 1, y is equal to 1, therefore this point is 1, 1. And if I substitute here it is 1, then it is 2. Here if I substitute here it is 1, then it is minus 3. And 2 minus 3 it will be 1, therefore here it is minus 1. Correct? Here it is minus 1. What will be the value here? At x is equal to 2, y is equal to 1, therefore this point is 2, 1. See, the coordinate of the point is 2, 1. But the value is, here if I substitute 2 2s are 4, minus 3 it is 1, the value is 1. Same thing if I plot the values of the function everywhere, that means for this particular point which is minus 1, 1, this point is minus 1, 2, somewhere here this point can be treated as minus 1, this point can be treated as 1, minus 1 and so on. Everywhere you can write these values. Typically if I write the value here, this point is 1, minus 1, therefore if I substitute 1 it will be 2, minus 1 it will be plus 3 and here the value will be 5. Then you will observe that the values of that function, that is z, depends on x and y. Correct? These are the values. Now as these values, that means as the quantity z here is the scalar quantity, such a function which depends on x, y is known as the scalar function because its value is the scalar physical quantity. I will give you a very simple example of temperature. Suppose here it is, suppose, or I can say that on a plane itself, if I keep a segment of rod, that means suppose here it is a rod along y-axis, and if the temperature of this rod is very high, say for example 1000 degrees centigrade, suppose it is metallic rod and temperature is very high, then you will realize that here the temperature will be, say for example about 900, then here the temperature will become, say for example 800, here the temperature will become, say for example 750, here the temperature may become 670 and so on. That means gradually the temperature goes on decreasing and I can plot this or I can write the different values of temperature at different point. But what will be temperature here? Again it will be 900. Therefore, for the value of x to be equal to 1, for example, for all values of y, the temperature will be 900 up to this and then it may differ. Therefore, here you may write how the temperature varies, and as the temperature is the scalar quantity, if I express this in the term of expression like T of x and y, T stand for temperature, then this can be treated as the scalar function of xy, scalar function of xy. Exactly in a similar manner, suppose if I think about variation in temperature along z axis, that means the axis which is vertical, I can write how the temperature changes with x, y and z, and therefore this can be treated as the function of x, y, z, function of Cartesian coordinates, and such a function is known as scalar function. Now here we may think about the density. Density is a scalar physical quantity, and if the density changes as a function of x, y, z, then I can say that density can be treated as the scalar function of position, that is x, y, z. At a particular point, the density has a certain value. At different point, the density may change, and so on. You may think about temperature, as I told you. Similarly, for any scalar physical quantity, you may have the scalar function. If it changes with the position, that means the coordinate, then I can express this as the function of x, y, z, that is function of Cartesian coordinates. Similarly, sometimes it will be better to express this in polar coordinates, cylindrical coordinates, etc. Typically in this case, as it is a rod, you will observe that here the value will be same and the value of temperature will be same around the rod everywhere. Correct? Therefore, it has axial symmetry. And in this case, instead of using the Cartesian coordinate, it will be better to use the cylindrical coordinate system. Suppose if I keep the rod at the center for a ball at the center of certain temperature, 1000 degrees centigrade, then you will observe that the temperature decreases as we move away from this rod. Therefore, it has radial symmetry. And in case of the radial symmetry, the polar coordinate system will be suitable, because everywhere at a distance of, say for example, 5 centimeter, the temperature will be constant. And in this case, the polar coordinate system will be suitable. But right now we will focus only on the Cartesian coordinate system, because we will have to operate the del operator on this function. And as we are aware about the del operator in Cartesian coordinate system, we will begin with the Cartesian coordinate system, and later at certain stage we may introduce the del operator in polar and cylindrical coordinate system too. This is about the scalar function. Now in the similar manner, I can give you the example of the vector function too. Obviously, suppose instead of having the scalar physical quantity like the temperature, density, etc., suppose we will have to express the vector physical quantity. For example, if I say something about the velocity of a molecule in a room or in a chamber, if I think about a three-dimensional view of a classroom or any box, then we will observe that the velocity of a molecule depends on its position. For example, I can think about the Cartesian coordinate system again for simplicity. I can say that the molecule which is somewhere here will be moving along this direction with certain velocity. The molecule which is here may be moving along a certain direction with a considerably large velocity. Here the molecule has a velocity along this direction and magnitude is this. Here the molecule may be at rest, the velocity may be 0. Here the molecule may have the velocity along this direction, here along this direction, here along this, any random velocity. It depends on the forces which are driving the molecule. For example, suppose the fan is rotating in the classroom or in a hall, you will observe that the fan is throwing the air in downward direction. And as the air is moving in downward direction, it is spreading away from a certain point, and therefore if this is the top, then this will be the velocity direction of the molecule. Therefore here the velocity will be maximum as I move away from the roof then the velocity goes on decreasing. Here the velocity will be maximum, here it will be decreasing, here it will be decreasing, and so on. You will observe that. Now if I will have to express the velocity as a function of position, then simply the numerical value is not possible. That means the scalar value is not possible. The reason is velocity itself is a vector quantity. And therefore at that stage, what I will have to do, I will have to write a function of xyz. I will have to write a function of xyz. I will not write symbol right now because I am not using the small letter f to represent the vector function, and therefore I will write it later. What I will have to do, I will have to write along with such type of 2x minus 3y etc. I will have to write, say for example, it is 3x square y will be the value, but if it is along x-axis, then I will have to write it is I cap minus, suppose the value is 2 y, it is along j cap, that is minus j cap, and if the value is plus 4 along k cap, if, correct, there are so many functions, you may write large number of functions, any parameter, any coefficient of I cap, it may be constant like this, it may depend on only one variable, it may depend on two or more variable, maybe linear, maybe quadratic, raised to 3, raised to 4, etc. So many functions can be written. But here you will observe that this is the value, but that is along x-axis. It depends on x, y, z, and it is along y-axis. That is, coefficient of I cap depends on x, y, z, coefficient of j cap depends on x, y, z, and coefficient of k cap depends on x, y, z. Here it is also depends on x, y, z. Just we have observed in the previous example, if it is a constant, for example, if you will have to draw a line, equation of line y is equal to 3. This is the equation of line, and it is a horizontal line passing through 3. It is independent of x, but still I can say that it is a function of x. Exactly similar to this, we can write this is a function of x, y, z. And the convention is that this is to be represented by a capital letter, say for example capital P, capital A, and obviously bar on it. The reason is that this is the vector quantity. Therefore, this is the vector quantity. It depends on position, that is coordinates, Cartesian coordinates, and hence it is known as vector function. Now, if I write a random vector function like this, 3x square y I cap minus 2y j cap 4k cap, or you may write any function, for example x y z cube I cap plus 2j cap minus 3xy square k cap, any you can have any coefficient of I cap, j cap and k cap. It may be constant, it may depend on x, y, z with any power of x, y, z. But such function is a random function. It may not have certain physical significance. But there are definitely some functions, vector functions, which represents the physical quantities. As I told you, the velocity of the air molecule at that particular position, electric field, magnetic field, and so many parameters are there. Acceleration will be there, then so many parameters are there. Every vector physical quantity, if it depends on the position in a coordinate system, then it can be treated as the vector function. Now, in 3 dimension, it is difficult to plot the vector scalar function, as well as it is difficult to plot the vector function too, because I cannot draw the 3-dimensional figure in 2 dimension. Just a component of vector is possible. But if I think about a vector field in 2 dimension, it is possible to represent, and like this type of a scalar function, I will show you how to plot a particular vector function in 2 dimension. For example, if I write a bar is a vector function which is x I cap plus y j cap. It is very simple vector function. I will be representing a very simple vector function first. Then how can I plot this vector function? I will have to plot xy axis. This is x axis. This is y axis. You will observe that for 0, 0, that means if x is equal to 0, y is equal to 0, it is 0. For 1, 0, I will not prepare the table, but directly you can observe. Suppose the point is 1 0, this is the point 1 0, then x is equal to 1, y is equal to 0, therefore it is 1 I cap plus 0 j cap. That means 1 I cap. This will be the vector at this particular position. What will be the vector at 0 1? Therefore this point is 0 1. X coordinate is 0, y coordinate is 1. And for 0 1, I will have to write it is 0 1. It will be j cap. That means it is along j axis. What will be the vector for 1 1? Therefore this point is 1 1. And for 1 1, it is 1 I cap, that is along x axis, it is I cap by unit, plus 1 j cap, that means plus 1 j cap, and this will be the vector function at 1 1. This is at 1 1. Similarly, you will observe that at 1 minus 1, it will be 1 minus 1. At 0 minus 1, it will be like this. At minus 1 minus 1, this will be like this. At minus 1 0, it will be like this. At minus 1 1, it will be like this, and so on. Now you can check this later on by slow motion of this video. You may think about this point is minus 1 1, and therefore you can substitute it is minus 1 1, therefore it is minus I cap plus j cap. It is minus I cap plus j cap, and therefore this is a vector. Right? I will draw one more vector field or vector function. Let b bar is equal to y I cap minus x j cap. Now these two vector functions have certain meaning, and therefore I am drawing these vector functions. One more thing for this, it is independent of z. Therefore if I raise the z axis somewhere here, everywhere the lines are moving away from the z axis. That means suppose this is our z axis in vertical direction. This is our z axis in vertical direction. The lines will be moving away from this z axis, because the reason is very simple, it is independent of z. If it depends on z, that means suppose if I write it is plus z k cap or z square k cap, then this has one more component, it will be moving along this, it is away from the origin, correct? It will be away from the origin. Now this has certain physical significance. We will discuss what is the physical significance after some time. This you can draw this. Now what you will have to do, you will have to pause this video, try to draw this vector function by your own, and then again by resuming the video you may check whether you have drawn the proper vector function or not. Okay, now check whether you have drawn the proper vector function or not. For 0 0, that means for the origin x is equal to 0, y is equal to 0, it is 0 I cap plus 0 j cap, therefore it will be 0. Fine, like this. But for 1 0, what will happen? For x is equal to 1, y is equal to 0, this means for this point I will have to substitute it is 1 0, x is equal to 1. Therefore I cap is 0, coefficient of I cap is 0, but coefficient of j cap is minus 1. Therefore here the vector will be like this. What will be at 2 0? If I substitute this to be 0, this is 2, therefore it is minus 2 j cap. It will be along this direction with 2. Can you plot this somewhere here? This point is 1 1, therefore it is 1 1, means it is I cap minus j cap, I cap minus j cap, and the vector will be along this direction. What will be the vector at this point? This point is 0 1, therefore I will write it is 0 1, means it is I cap along this direction. Similarly for this, you will observe that the vector will be along this direction. For this, the vector will be along this direction. For this point, the vector will be along this direction. For this point, the vector will be along this direction. For this point, the vector will be along this direction. It is interesting. You will observe that this vector field has a certain sense of rotation, and therefore I have used this vector field. Now when we discuss some or when we discuss the operation of del operator on this vector field, then you will realize what is the significance of such type of vector function, what is the significance of such type of vector function. But typically, now in this video we have observed what is the meaning of scalar function, what is the meaning of vector function. Now for the sake of use of this function, in this unit we may not use the real physical functions. That means the functions which represents real physical quantities. We may use the random function. For example, you may write f is equal to, it is x square yz minus 3x square y plus 4z cube. You may write any function. We may write certain vector function as p bar is equal to x y I cap minus 3x square j cap plus 2xy z cube k cap. This is a random function. But being a unit of mathematical physics, just we will have to have some functions and operation of del operator on these functions. These functions may not have certain physical significance, but definitely the functions who has the physical significance are like this, and we can extract some information from that by operating del operator on these functions. We will discuss this in next video. Thank you.